Everybody knows what logs are, right? Logs are usually text-based output from our program that usually are archived somehow so that we can come back and figure out what's going on at a later time. Depending upon your situation, logs can sometimes be the only thing that you have to try to troubleshoot a problem in your system. If you've got remote programs running somewhere and you're selling software that people are installing, a lot of times the best you can hope for is to get that software running and tell them to turn on the debug feature and just send you a bunch of logs and hopefully figure out what's going on from that. So logging is a really important diagnostic tool and really helpful. Python has a really powerful logger, but it can also be kind of confusing because there's a few different parts, and it's not always very easy to understand how they work together. So the first thing that we're going to do here is just kind of review. We're going to go from pretty simple to pretty advanced. Just kind of progress through this to figure out what's going on. Does everybody know what virtual environments are? Okay, let me ask the question differently. Does anybody not know what virtual environments are?
I don't know.
Okay, so virtual environments in Python, because Python was typically installed at the server level, the packages or the dependencies that you'd install were installed at the server level. Well, in today's world, most of your Python applications, you want the dependencies to be self-contained because something might require SQLComedy 1.0, but something else needs 1.2. And so virtual environments are a way to basically package up dependencies for an app-specific purpose. So if you Google Python virtual environment, you'll find the package that manages that. There's only one really that's worth learning, and other tools that are available. But it's very good to get used to using virtual environments for each app. Each app you build should have its own virtual environment, its own set of dependencies. Learn how to use virtual environments. It will save you a lot of headaches in the long run. Vex is a tool that I use to manage activating my virtual environments. And so what I did there at the bottom is, I bet some of you can't see that, can you? It's a little bit too low, the terminal at the bottom. All right. I may have to do something different with the terminal. Let me know if you can't see the terminal, and I'll pull up a different screen with one in it. So I activated my virtual environment, and now I am just going to run this first script here. So the import print function, you don't really need to worry about that so much. I wanted these scripts to be able to work on Python 2 and Python 3. In Python 2, the print is a statement, not a function. In Python 3, it's a function. But by importing from future the print function, it enables the print function, the print statement to be a print function in Python 2. I'm not using print statements in this file, but I kind of just threw them all in every file so I wouldn't forget about it later, if you're wondering what that is. Import logging gives me the logging module from the Python standard library. This is not a dependency I have to install. It's installed in Python by default. And then there's different levels of log messages. So Python, if you read the docs, you'll see that they have 4 or 5. I think they actually have 5 different levels of logging by default. They have debug, info, warning, and error, and then I think they have a critical too, which is above error in the hierarchy. You'll notice that on the screen, I only ended up with two pieces of output, even though I output 4 error message. Anybody want to take a guess about why that might be? Or you can tell me if you know. So the question is, if you look at my code, you'll see that I logged 4 messages. But when you look at my terminal, I only got 2 pieces of output. I got the warning message and I got the error message. But the debug and the info message did not come through to the terminal. Anybody want to tell me why?
Is it related to this whole managed by exception?
No.
Is it logging level?
It's logging level. Yep. So in Python, these log levels act as filters at various levels to basically filter out messages given their severity. And we'll talk about a little bit more about levels in the future. But by default, the root logger, and we'll talk about what the root logger is here in just a second, but the root logger has a default level set on it of warning. So when you set a level, you're not setting that particular level, you're setting that level and everything above it. So by setting a default level of warning, the root logger will warn at the warn, error, and critical levels. So anything at those levels will show up. Anything underneath that will not. All this stuff is, if you Google like Python logging module or just Python logging, this is all in the docs. You can get all the details on this. All the logging levels are listed. Python has pretty good docs for programming language. So you can go get the details on that if you want to. Okay, so I just switched to the levels file, and so I'm doing a couple things differently here. The first thing is I'm going to use a function that the Python logging module gives me called basic config. Basic config does some setup of a handler and a formatter, and we'll talk about what those are later. But it does some basic configuration to help get Python set up, the logger set up to actually output information in kind of a sane way. So it allows you to have one command instead of 3 or 4 lines to get it working. It is helpful for situations like this, but when you're starting to move towards a more production environment, you need to learn what basic config is doing behind the scenes and learn how to do those things yourself, which we'll get to. But for right now, all I want to show you is that I've set the level of logging to info, and then I've tried to set it to debug. So remember the hierarchy goes debug, info, warning, error. And so what I'm trying to do here is I'm trying to set, initially I want to set it at info, which should give me 3 messages, right? It should give me the info message, the warning message, and the error message. And then I want to set it to debug and get 2 more messages, the debug and the info. Does everybody understand what I'm doing here? If you don't understand, if you've got a question, let me know now about what I'm trying to do. Okay? Anybody know where the bug in this is going to be? This is not going to work as expected. Anybody want to make a guess as to what will not work? Or tell me if you know.
Were you able to set the basic config twice?
Good call. I am, but it doesn't take a second. It doesn't apply the second time around. I should know my editor better than this. I want to toggle the panel. Control J. Okay, well, that makes sense because J is the panel. I guess I can make this a lot bigger. Okay, so I do get the first 3 messages like I intended. I set it to logging.info first, and so I skipped the message that got skipped is the debug message, right? Because it's below debug is below info. And then when I went to set it the second time, your name was again? John was right. The basic config will not apply if there's a handler already associated with the root logger. Once again, we'll talk about what those things are in a second. But the first time you call basic config, one of the things it does is add a handler to the root logger. So the second time that you call it, basic config sees that handler and says, I'm hands off, no pun intended. And so the second time around, when you call the debug and the info, that debug setting never got applied, and you're still just at the info level, which is why some info 2 got logged and not lots of detail 2.
So I see that as a real problem coming from other languages where you get instantaneous change of severity level. Is there a way to get rid of that handler and redefine it?
Yeah, so actually all we have to do is set the level differently. So basically this is a limitation of the basic config function, and it's intended in how it's intended to be used, and that's why we're not. That's why it's not working as expected, and it's also why I usually don't recommend using basic config unless you're just doing a script and you have very simple requirements. So just knowing the limitations of basic config is why I demonstrated this. All right, so let's see. Control J and Control B. All right, so let's look at loggers now. So implicitly behind the scene, if you noticed the last time, notice that my log calls, my debug, info, warning, and error were off the root logging module. and even if you look at the first one, excuse me, if you look at the first one, I didn't even call basic config. If you call the methods off of the root logging module and not off of a logger, it will call basic config behind the scenes with no settings. So that's why this and this work, even though you're not dealing with a logger, you're just dealing with the logging module at the top level. You would almost never do this unless you just had a single script. You wanted an easy way to output some stuff to a file. You typically do not work with the log methods that are on the logging module. You get a logger, and then you work with the methods on the logger, which is what I'm going to demonstrate now. Okay, so the first thing that we're going to do here is we're going to use the getLogger method on the logging module to get log, and that log is what the Python docs refer to as a logger. That's an instance of the logger class, which has a certain number of methods and functionality that it supports. So I'm going to call the log.error method with a message, and now notice that I'm not calling that method again on the module. I'm calling it on the logger. And then I'm going to show you that the handlers, there's no handlers currently on that logger, and this message is not going to output. You're not going to see it because there's nothing to display it. So this is really important to understand in Python. Python split it up into 3 primary object types. You have the logger, the handler, and a formatter. The logger and the handler are not the same. You can log stuff all day long, and those messages will not go anywhere until you get a handler set up on the logger. So you'll see that there's no handlers now. I'm going to call the basic config function, and then you'll see that there are some handlers. I'm going to do the same thing that I did in the last file, which is I'm going to call three methods on the logger. Which one is not going to show up? Somebody tell me. Lots of detail. Anything else? Do what? The info's not going to show up either. Why?
Because it's the default logging model, which I presume default this morning.
Yep, that's right. So I didn't notice, even though I called basic config, I have not done anything to the warning levels. The default warning level on the root logger is warn, and so the only message that's going to show up out of these 3 is the warning message. Now I can call setLevelLogging.info. That will have an immediate effect, and I will now get log.info to show up, but not log.debug because it's still lower than log.info. Okay, so notice that I got an error message. No handlers could be found for logger root. So this is helpful. This is Python's way of trying to help people who don't understand why their log messages are not showing up, to have a hint that it's because the handler has not yet been set up on that root logger. Remember, I printed out the handlers. Bring this down just a little bit. And right there, I printed out the handlers, and there's none. There's no handlers on it. I called basic config. Part of what basic config does is create a handler and add it to the root logger. So now, when I print the handlers of the root logger, you'll see now that I have a stream handler inside of that list. The reason that it's a list is because loggers can have more than one handler. So I could have a handler on the logger that goes to standard out, which is this, it ends up in the terminal. I could have a different one that goes to a file. So you can have multiple handlers on a logger. Okay, the first series of messages, again, because the default level is warning. And then I set my logging level to info, and I see that my info message came out here, but my debug message stays hidden. Any questions on this so far? That's not okay. All right. One thing thing to understand about loggers is that they exist in a hierarchy. And this is really important for understanding how to control and filter and where to add handlers. So the first thing that I'm doing here is I'm just creating a function that I'm going to feed some loggers to, and it's going to print out some information for me. It's going to print out a header message, and then it's going to print out some spacing just to help the formatting and terminal be obvious where the messages are. It's going to give me the name of the logger, and it's going to show me its parent. Okay, so I'm going to call this method later, and I just want you to remember that this is what we're doing. This is how we got this information. So the first thing I'm doing is I'm calling basic config, and this time I'm setting the level to info by default, so that we can use the info level and actually have it show up. I then get the root logger, and then I'm going to start to make some other loggers. Now notice that when I make loggers, the hierarchy is set out based on dotted strings. It's not based up. I don't take the auto logger and kind of do a create child with it, right? I'm always calling get logger, and I'm just giving it the dotted representation of that logger's name. Python behind the scenes is creating loggers as necessary to meet the needs of the dotted hierarchy that I'm giving in the string. This is actually really important because what it means is that you can get access to loggers from other libraries, which I'll demonstrate here in just a little bit, without actually having to have a hold of the object. This is really helpful when you're trying to debug certain parts of an application or certain libraries, and you want to set up all that logging at the application level, usually in the configuration stage of your application. So I've set up 3 loggers here for autos, Auto, Toyota, and Honda. Then I've also set up 3 loggers for a company, Google and Amazon. I've set up another series of loggers for a hierarchy that gets us from the USA down to Louisville. And actually comment that out at first. And then I'm going to log all those handlers I just made so we can see how the hierarchy kind of positions itself. Make those silent for a little bit. Okay, so remember this logger info is just going to do some printing of these loggers for me. Okay, so here's my loggers. Notice at the top that I've got the root logger and its parent is none, right? The root logger has no parent, it's none. You've got auto, which has the parent as root. Auto.toyota has auto as expected, so does Honda. Company now has the root logger as its parent. Google and Amazon have company as its parent. And finally, USA.Kentucky.Louisville has the root logger as its parent. Any of that surprising to anybody? Questions about how this hierarchy, how the loggers work? If you use dashes in there instead of dots, it will not recognize it. You won't get the hierarchy to work as expected. You'll have a bunch of dashed names that all have the root logger. So the only separator that you can use is the dot. Now I want to show you something here, and this actually surprised me. I learned this while I was making this tutorial. So now I've created another logger. Notice that right now USA.Kentucky.Louisville has root as its parent. I'm now going to bring into existence a different logger. Where did it go? Right here, USA.Kentucky. But notice I'm even creating that logger after I create the Louisville logger. And I'm going to run this. And now the parent is USA.Kentucky because the logger exists. The reason that's important is because from a performance perspective, you wouldn't want to always be sending messages all the way up through a hierarchy if those loggers aren't being used anywhere. So the loggers are only created, the middleman loggers are only created as needed. Okay, so All right, so all we're doing really here is we're logging. We're showing that the formatter that the basic config sets up gives us the level, the name of the logger, and then the message. So that's why we're seeing that information in our logger or in our console. Clear it. Well, I want to show the next. There's only one line of code here, or two, I guess. Okay, so the loggers by default propagate up to the parent logger. So if you send a message to Louisville, it will propagate up to all of the parent loggers by default. If you turn that off, if you turn propagate off, it won't. That makes a lot of sense. So let's run this again. And notice that now we got a message here at the bottom that no handlers could be found for logger usa.kentucky.louisville. And that is because that handler no longer is allowed to go, because we turned propagate off, that logger is no longer allowed to go up the hierarchy to find the logger, to find the handler that's on the root logger. Because remember, that's where basic config set that handler. It set the handler on the root logger, but our Louisville logger no longer has access to the root logger. It can't walk its way up the hierarchy. However, we could fix that by adding a handler directly on the Louisville logger itself, and that would allow us to work around that problem. So we have the same message, we set the handler, and now we log success on the Louisville logger, and it works. Questions so far? Yeah.
When you say propagate, do you just mean if there's multiple handlers in the hierarchy, it will send multiple messages, or do you just use the first one it finds in the hierarchy?
So a logger will always use every handler it finds in the hierarchy. So yes, you can result in multiple messages. Sometimes that's a bug, you don't intend it. Sometimes it's accurate. Like if I wanted to log both to the terminal and to a file, I would want both handlers to be used. I've run into situations where I've got handlers on two loggers and I'm getting duplicate messages. And it's really annoying. Two handlers on loggers in different places in the hierarchy, and it can be really frustrating to figure out what's going on sometimes. Does that answer your question?
Yes.
Okay. Okay, so now we have success. And so actually, look, I'm going to demonstrate that. So that's why I have this in here. So now I'm going to turn propagate on. I'm going to turn it back on. And I'm going to log another message. What's going to happen? Anybody? We're going to get two. That's right. We're going to get two of the 2x success. This one, notice that they're formatted differently. This one comes from the handler on the Louisville logger itself. By default, the stream handler that we created does not have a formatter, and so it will output just the message. But basic config sets up a formatter that has level, logger name, and message, and so that's why that second 2x success message, that's why you see all of that. The two strings are different. Does that make sense? Okay, so what's happening is I'm logging on Louisville. Louisville runs through its own handlers. It finds one. It tells the handler to execute, do whatever it's supposed to do with the message. It does. It prints it to standard out. Then it looks for all of its parents. It finds the root logger, and it runs through all the handlers on the root logger, which the only one there is the stream handler that the basic config set up. So that's how the node, and that's all happening in the logger itself, and we'll talk about why that's important. So the Louisville logger itself is actually calling all the handlers. It's not handing off the message to the root logger and then letting the root logger handle it. And I'll show you why that's important. That's another thing that I learned while I was doing this tutorial. Okay, so I said a little bit earlier that it was helpful that the logging works through strings and through dotted strings, and here's why. If I wanted to troubleshoot the SQLalchemy library, which is it's a database ORM library, I can go and grab SQLalchemy's its loggers, and I can set handlers on them. I don't have to actually import them. I don't have to figure out what their code looks like. All I have to know is that SQLalchemy is exposing their loggers through the namespace, and this is very standard in Python. In Python, when you do modules, you do from SQLalchemy.engine import or from SQLalchemy.orm.declarative import. Well, that's all dotted notation. It's very common in Python to have your loggers match that import namespace exactly, and there's even a shortcut to do that, to set up your loggers to do that. And so if I know how to use it, if I know how to use SQLalchemy from an API perspective, 95% of the time I also know how to pick the loggers up that I want and get a hold of them and set handlers. So I'm going to do a few things here. First of all, I am going to initialize an engine, and I'm going to call I'm going to basically issue an SQL statement to the engine to select the SQLite version. So by default, I'm using an in-memory SQLite database here because I don't really care about the data. And then I am, and initially, remember, I haven't done anything with handlers, so I don't have any logging set up. And so we're not going to see any output from this first create engine and execute statement. There's just not going to be anything, which is how you really want it in an application. I don't want everything that everybody's called a logger on to start outputting information. I just want the very specific things I want information about. So by default, we're not going to see any output. Then I'm going to go grab the SQLalchemy engine logger, and I'm going to set info. I'm going to set the info level on it, and then I'm going to create the engine. Oh, okay. I did set up call basic config up here. So I am calling basic config so that we get what? What? A handler. And where's it going to be? Root logger. And what kind of handler is it going to be by default? A stream handler. Yep. Which goes to the standard error stream. Actually, I've been saying standard out, but it's actually standard error. And then I'm going to grab the pool logger, and I'm going to set the debug level on it. Now this is, once again, this is a nice feature where I can set different levels of logging based on the logger itself. And then I'm going to select again, and you'll see that the output kind of matches what we expect here. It's because apparently when I used that command earlier to run Python in the terminal, it opened up a new bash instance. Okay, so there's a lot of information here. Let's go through a little bit slow. So remember there was no logger. Initially, I didn't have any settings. So initially, I don't get anything.
Right, so are the SQLalchemy are their loggers, are they set up not children of the root logger?
They are. So I just kind of misspoke. I was just going to say that. So the issue here is actually log levels. So the issue is that SQLalchemy by default is logging everything at the info and debug level, and we haven't hit anything. They probably do have some warning or some error logs, but what we're doing is not hitting them. If they had, we would have got that output. So it's actually the logging level that is resulting in no output. So by grabbing the engine logger and setting it to info, now we're going to see some info messages from the logger, which are all right here. So the first 3 or 4 messages, first 3 messages are because SQLalchemy is doing some testing of SQLite to figure out how it works. The first time that you execute a connection, it's going to do that. So I didn't call these by default. That's SQLalchemy working under the hood. This is my SQL call here, the select SQLite version. And I think the reason that we're not, all these empty parentheses are because I haven't sent any parameters. If I had used a parameterized SQL statement, we would see something in those parentheses. Okay, then if you remember, I did a pool logger, and in the pool logger, I set a debug level. So now, in the pool logger, notice that in the middle of this block, I get the same info level messages that I had above, because the info level is still applying. Just because I set the debug level on the pool logger doesn't change the fact that I had already set the info level on the engine logger. Questions about that? Anybody lost?
Another quick question about the create engine you're creating as SQLite. It's not creating a file, right? It's just creating a version, a RAM or in the program space.
Correct. Yeah, it's creating.
So could you do it to a file?
I could have SQLite. Yes, SQLite can be. I could give it a file instead, and it would take care of creating a file and structuring it as needed.
So it'll just do like a index and a string of text as a table. How would it create this table?
So SQLalchemy is not a logger. SQLalchemy is the database engine, and so create engine actually creates a file that's a database.
So it did create a file.
No. SQLalchemy, SQLite by default, because I give it this configuration parameter,
Right.
it will create that data structure in memory.
Right, but if you gave it a file name, it would create a file.
It would create a file.
So what would structure that database?
Oh, I have
So
no
it
idea.
would be index maybe.
I mean, yeah, SQLite is a C library.
I'm familiar with that. I just was wondering if it actually structured the table itself.
I'm sure the file is structured. I don't know what the structure is.
Okay, that's fine. Thanks.
So I'm running this in PyCharm because I've been playing around with it. To be aware, you were mentioning standard out versus standard error.
Mm-hmm.
My stuff's coming out, the pool logger comes out, the hashtag pool logger comes out at the very end.
Yes.
Right.
Yeah.
Because it's a different stream.
Yeah, because it's a different.
Be
stream.
aware that things can come in a different order when you're dealing with two different streams there.
Good call. Okay. Okay, so now we are going to do a very similar process here. We're going to start. We're not going to have any logs. Then we're going to do an engine debug. So I shortened this a little bit. So notice I'm getting the logger and I'm setting the level at the same time. So I don't really want to do anything with the logger other than set the level. So I'm just stringing it together. And I'm going to set debug on the engine. And then I want to, at the root level, let's say I wanted to filter that out. I wanted to filter out those messages. So remember, where is basic config setting the handler? On root. Okay. So I'm gonna leave the SQLalchemy.engine at the debug level, but I'm gonna take its parent root and I'm gonna set the level to error. What's gonna happen? I'm still going to get debug out of SQLalchemy. Why?
Because the level on that logger is still set to debug.
That's right. So this is part of understanding how levels and hierarchies work. The level only works on the logger that actually gets logged on. That level does not apply to messages that propagate up the stream. So if I had a whiteboard, the way I would draw it is you have a parent, you have a child logger, you have a branch off, and you've got the level filter, and then you have the actual calls, the debug info, whatever calls. And so that filter only operates when the message comes into the logger itself. It does not apply when children are passing messages back up. And actually, it's because the child doesn't actually pass it up. What it does is, if it passes the filter, it runs all its handlers, checks every parent or every ancestor, and runs all its handlers. And in that process, it never looks at the level on the parent loggers. Okay, so we had the engine debug, and we set root override, and he was right. We just see the exact same thing. So basically, setting that root override, that level, did not matter. What would it have mattered on? Anything that, if we had tried to do a root log, or if we had tried to do a root logger.info, it would have applied to that. It would no longer have showed up. Or even root logger.warn would not have showed up because we ultimately set it to error, which is one level higher. All right. Having fun yet? Okay, so what this is meant to show is that we've talked about the level of a logger and how it gets that level, if you will. So in the past, most of the examples that I've shown you have only had a level set where? There was only one place a level was set in most of the examples I showed you.
I mean, the last one had others.
Yeah, on where? On what?
On the root.
On root, yeah. So most of the examples I showed you, there was only one level. Well, if you remember, if you think back to our USA.Kentucky.Louisville example, we logged to Louisville and it came out, right? How did the Louisville logger, which did not have a level set on it, figure out what its level was?
As a default.
Say it. Say it again.
As a default.
It has a default. What's the default? Do what? No, it's not actually. But that's a good guess. That's what I would have guessed. What? No. Well, no, not technically. It's actually set to 0, which means not set. And the logic, although it's not set to the parent level, there is a logic called effective level, which will look up the hierarchy to figure out what is the first parent that's set, and it will inherit that usage. So notice that there's two types of kind of inheritance or hierarchy usage going on here. One is the logger figuring out the level at which it's set. The other one is the logger looking at the hierarchy to figure out which handler should emit its message. And those two things are distinct uses of the hierarchy. Okay, so the first thing I'm going to do is, so I've created 4 loggers here. I've created root, USA, Kentucky, Louisville, and the expected hierarchy level. I am going to show you, so all of these levels, even though you're seeing logging.info, logging.debug, logging.warn, or warning, they're all just integer values. So this very first print message, you're going to see the results, what the integer values are, so that later when I'm printing out these levels and you're seeing integers, you can translate them. So my goal here is I'm going to start off just showing you what this looks like from a default perspective. You create 4 loggers, they're all in a hierarchy. What is the logger's level and what is the effective level of that logger? And we'll see that that's usually different. And then we are going to gradually set different logging levels. First on USA, it's really annoying, that whole pop-up. Look, that's just dumb. Like, that's dumb. I don't want that. I never want that. Anyway, sorry. What? I'm sure I could. I'm not going to at the moment because I'd take more time and you guys would be bored and be like, wow, this guy's working with his editor. Although Visual Studio Code, which is what I'm using, it's a pretty good editor. I like it a lot. So I'm going to set the debug level on USA first. And then I'm going to set the info level on Kentucky, and then I'm going to set the warning level on Louisville. So we're going to see, and each time it's going to ask me to continue. So we'll kind of examine what's going on in the console, and then I'll hit enter, and we'll look at the next level. So just remember what I was doing here. I'm setting different levels. Each step is going a little bit higher. Okay, so by default, our integers are not set to 0, debugs 10, infos 20, warnings 30, error is 40, and critical is 50. 50. Now you can set, if you had a need to set other levels, Python does give you the ability to basically create any integer level in that range, or I think really any range, probably any integer range that Python will support. It's just an integer, and when you create that level, you tell it both the name and the integer level, and it just kind of inserts it in the hierarchy, and that's why all of this stuff is kind of a greater than filter. So you can add more filters if you need to. I typically don't think you do. I think it's good practice in logging to stick with, don't overcomplicate logging. Stick with debug, info, warn, error. Those seem like pretty good logging levels to me. I've never had the need to have anything greater. Always log more information than you think you're going to need, because you can always, it's easier to filter out information you have when you're trying to troubleshoot a problem than to guess about what's going on because you don't have the log messages. Okay, so notice right now that the root logger, I did not print out the effective level of the root logger. It's 30, its effective level is going to be 30. So by default, we've said this all along, the root logger has a default level of warning if you have not configured it, which is what default means. So that's doubly redundant. Okay, so USA is not set. It's going to, its effective level is going to be the warning level, which is inheriting from its parent. Ditto for Kentucky and ditto for Louisville. Okay, anybody remember what I did next in the code? Good, yep, so USA.set level, so I'm setting USA logger to debug. And so now you will see that the difference between the first go around and the second is that USA now has 10 set on it directly, and its effective level is now 10 instead of 30 because it's not inheriting. But look at what we did to Kentucky and Louisville too. Their effective levels are no longer 30 like they were up here because they're now inheriting the closest set level, which is USA, and its debug level. Okay, so next we're going to set Kentucky to info. What's going to happen to Kentucky and Louisville?
Yeah.
They're going to go to 20. Yep. So Kentucky's 20. Louisville still not got a level set on itself, but its effective level is its nearest ancestor, which is Kentucky, which is 20. And finally, we set debug directly on, warning. Yeah, we set warning directly on Louisville, and so now Louisville is back to warning. Any questions? Okay, so we've talked about handlers. We really haven't explored handlers that much. Handlers are just a way to take a message and get it somewhere. So I have a message, I want to get it to standard error. I have a message, I want to get to standard out. Does everybody know what standard error and standard out are? Anybody not know what standard error and standard out are? Okay, so standard error and standard out, typically your program has two ways to stream data out of it, if you will. Is that the right way to say it, Bill? It's a byte stream, and it's a way for other programs to interact with your program. So there's any program usually has three streams. You have an input stream, standard in. You have an output stream, standard out, which is where most of your output will go. And then you have a standard error stream, which indicates that you're writing bytes out, but those are error bytes, as opposed to the standard out, which is non-error stuff. So we are, handlers are just a way to get from a logging system messages out somewhere. So the stream handler by default does standard error. You could easily change it to do standard out instead. There's email handlers, which will send an email every time a message hits them. There's file handlers that will log to files. There's rotating file handlers, which will log to files and take care of file rotation, which can be really nice if you don't want to go through the hassle of setting up log rotate on a Linux system. There are socket handlers that will send that message out to a socket. There's syslog handlers, which will send it out to a syslog server. There's HTTP handlers, which will send it out to an HTTP one. You can write your own handlers. All you really need to do is there's a log record class, and all you need to do is inherit the handler and basically override the emit method, and it'll give you a log record, and you can do whatever you want with it. You can turn it into little bunnies if you want to. So it's really, I mean, it sounds complicated, but when you look at it, it's not. You can easily find examples of custom handlers, and there's docs in the Python. There's a whole page just on all of the handlers they provide by default, which typically are going to cover most use cases. Okay, so let's look at what I'm doing here. I'm setting up the same hierarchy that we've seen a few times now, so I'm not going to explain that. I'm setting info on the root logger, and now I'm setting up some stream handlers and some file handlers. So I put the stream handler on root, and I also put a file handler on root with the name, the file name, excuse me, is going to be root.log. Do the same thing for the USA handler. I want a file handler, and I want a USA.log, Kentucky same, Louisville same. So I'm going to end up with how many files when I run this? 4. Now I'm not using an absolute path, so where are those files going to end up? In the same directory, in the current working directory is where they're going to end up. Okay, so I am going to, now I'm just adding some log messages so that I actually have something in the files. Now I'm going to set the warning level. Notice that when I'm setting this warning, what am I setting it on? I'm setting it on the handler, right? So what's that going to do for us? What was the stream handler? What logger got the stream handler? Anybody remember? The root handler got the stream handler. So we are going to change that to warning. And what we will see is that the Kentucky file gets Kentucky 2 because the handler that we used was not the file handler for Kentucky. The level had nothing to do with it. Well, this is kind of dumb. It doesn't do anything. I messed something up here.
Isn't Kentucky file handler going to inherit from the root?
Yes, you're right. Thank you. So what that's going to do is that's going to end up, that message is going to propagate up to the roots handlers, and the stream handler will not work for Kentucky 2, but the file handler, the warning message will show up. So what we're going to see here is Kentucky 2 is not going to end up coming to standard out, but it will end up in the file, and we will see the Louisville 2 message also in the file and on console. All right, let's take a look at that. Any questions about that? Let me show you what we end up with, and then we'll get a few questions. Look at that. Okay, so what we see is root, USA, Kentucky, and Louisville all coming out because we made initially 4 calls, and we set up a stream handler on the root logger. We set its level to info, and so we got all 4 of those calls just as we expected on the stream handler. Oh, you know what I want to do? All right, I'm gonna run this again. That way our files are clean. Okay, and then on the warning level, as we talked about, the stream handler is only showing Louisville 2 because it got set to warning level, and it's not going to show info. Just the handler, not the logger, just the handler. And we'll see that the root file. I guess I'm not opening it. All right. So if we look at, let's start with Louisville. What's Louisville.log going to have in it?
Kentucky 2 and Louisville 2.
Nope.
Okay.
But you're close. What? Nope. Louisville and Louisville 2 is what it should have. Okay? let's see. I was on handlers. All right, what are we going to see in Kentucky? Kentucky.log. Kentucky and Kentucky too.
Yeah, yeah.
Oh wait, that's right. We're wrong. Why? Is you get not only the messages from yourself, but also from your children. So both Louisville messages got carried up.
Mhm.
Okay, so I get Kentucky, Louisville, Kentucky 2, and Louisville 2. All right, what are we going to see in USA? USA, Kentucky, Louisville,
Yeah, yeah.
Kentucky 2, Louisville 2, right? Yeah. Okay, and finally, the root logger is going to have what in it? The root log file?
Everything.
Nope.
Except,
Except?
except the, you said to warn, right? Yeah. Except the info, Kentucky
So
two.
what is stream handler, not file?
Okay. Root, USA, Kentucky, Louisville, Kentucky 2, Louisville 2. So I did set the warning, but it was on the stream handler, not the file handler. So the file handler got everything. Okay, questions on handlers?
I'm gonna go over, because you're setting the level on different things within a handler. Where you're setting it in the handler, and then they're setting it at the logger level.
So there's levels at the logger level and at the handler level. So the logger for root, we set to info. That never changes. And this file handler, by default, a handler does not have any filters on it, so it's gonna handle everything. You can change that, which we do later. So by default, the root logger gets everything that kind of comes up to it. And that handler has no filters, so everything goes in the file.
What happens if you have so a logger that has nothing set,
Has no handler set,
well, has no
level.
level set, inherits from its parent, right?
Yeah, so by default, the root logger is at the warning level. If you didn't do any other logger level settings, every logger is going to have the warning level. Does that answer your question?
I'm just wondering how what if there's a conflict between, can you ever have a conflict between the logger and the handler?
Sure. Yeah, so remember the logger only applies to itself. So you could theoretically, you could put a logging level that's really verbose, like debug, on root, and then you could set the handler to warning. Well, if you logged at the root logger at the debug level, nothing would be printed because the logger is trying to log, but the handler is saying you're too verbose for what my setting is. So these combinations are there to support really complicated logging needs for some reason. So let me give you an example. Let's say one area of your application, as defined by the dottedness. So let's say my app.sales. If you have info messages in sales, you want those all emailed to the sales team. But if you have my app.engineers, anything in the my app.engineer space needs to ship out to the engineers. Okay, you can support that. Just set a handler on one logger and a handler on a different logger, and they'll get what they need. So there's all kinds of different options that really should support just about anything sane you would want to do with logging. Most of the time, you only deal with log messages at the root level. So normally you're going to set 1 or 2 or 3 handlers at the root level. You're going to set the level of log messages that you want at the root level and just let it propagate all the way up. And then you're gonna set your levels for the level that they want. So it could be something like I want to set up info messages. They all go into a log file. I'm going to set that on the root logger. and I'm going to set it at, I have to set info on the root logger, because otherwise all those other log messages I do, they inherit the warning level, they won't actually log a message for me. So I set the info level on the root logger, and I set up a file handler on the root logger to send everything to the file. But it may also be that if I ever hit an exception message, if I hit an error level log, I want an email going out to the dev team immediately. So now I've got two handlers, a file handler and an email handler. The email handler gets a level set on it of what? If I only want the error messages to go to the dev team.
Error.
Yeah, it gets error message or error level. So in that case, your file handler has an info level, your logger has an info level, but your email handler has a error level.
Say that again.
Yep. Okay, so you understand the
Just the last-
scenario,
yeah,
right?
just the last
Okay,
one.
so in that case, I have a logger with a level, the root logger has level info.
Right.
I have two handlers. One handler is a file handler. It's assigned to the root level, and actually it wouldn't need an explicit level set because it'll have no level, and by default it'll handle everything. So the logging level on the root logger of info will apply to the file handler we're done. I also want to create an email handler. That email handler gets a level of error. It gets assigned to the root logger. That handler technically sees every message that the file handler does. It just doesn't operate on the ones that are not low enough. Actually, I think that's not true. Now that I'm thinking about the Python code, I think when you're looking at a handler, they actually look at the level of the handler and don't emit the record.
So the thing I'm wondering about is, you've talked about handlers and logger levels, right? So why do you ever bother with a logger level when all you need to do is seemingly is just write different handler levels to deal with the information you're getting in a log?
It's a matter of giving you two dimensions of control.
Okay.
Yeah.
It does represent a default for the handler, or for the logger. What you're saying in your example there, that file output that you have, you're basically saying by saying that set, you're saying whatever the root handler happens to be set at right now. And so anybody who decided to change the root handler, or the root logger, right, will automatically get inherited by everything else. It's kind of almost like setting a server level.
Yeah.
This very closely mirrors syslog behavior in a Linux box, right? You've got facility and level,
Mm-hmm.
and trust me, you want more than two dimensions at some point.
Yeah.
I want a third dimension somewhere, it's just not there.
Well, and you do this. So I am not covering this here, but they also have filters that can be kind of inserted in various places. The reason that, for an instance of how this has applied to what we do. So for instance, our apps always have a namespace. Like we have one called RRS Web Repo, I think is the name of it, or something like that. So I want warning level messages. Handling warning level messages at root is fine, but for my particular app's namespace, I want all the info messages. And so in that case, I would set my handler up to log everything to a file, because I want all my messages in a single file. I want to go back to get them. So I would end up setting that handler on the root logger, and I would not set a level, because I would say anything that's logged that makes its way upstream, I want to end up in that file.
Gotcha. Yeah.
And then I would go grab the handler for my top level namespace, and I would set the info level, and that would apply to all of my child namespaces inside of my application. So in that case, I would result in that file. I would result in all of my apps info messages, and also any warning messages from anywhere in the Python application.
I follow. That's what I was wondering. It doesn't seem like, the logging level, again, is not what you're really manipulating. You're manipulating the handler.
No, in that case, I'm setting the handler on the root logger, and I am setting the logging level on the logger that's at the root of my namespace.
Oh, all right.
So it would be like grabbing USA and setting USA dot set level logging dot info.
Okay. Right.
Because I want USA, Kentucky, Louisville, I want all of their info, and then I want warnings from everywhere else.
Gotcha.
With the email handler, for example,
Yep.
is there such a concept as under these circumstances to the sales team, under these circumstances to the engineers, but under these other, if then we need to the sales team, engineers team, whatever.
You can do that, although I wouldn't recommend getting too complicated for logs. Even though all this functionality is available to you, typically what you want to control what areas of the application are generating logs at what level. And once that's configured, then you want to probably ship all of your logs, and we're going to talk about this, to a main kind of repository. That way all the info is there and you can search for it if you need it. So it becomes less directed at the time the application is configured and more, let's just get it all in one place so it's available for review.
Mm-hmm.
And then you can do certain things like the tools that they have nowadays will actually let you do filtering for certain types of logs, and then the log tool will alert you. So now it's not your application alerting you, it's the logging tool, which is actually, I think, better in the long run. Okay, I'm going to move on from here. So logging exceptions is really helpful. So there's sometimes in an application where you're going to want to ignore an exception that's generated. But sometimes you kind of want to be able to track, well, maybe how often am I hitting that? So for instance, if I had an API, or if I had an application that required me to hit an API, a web API to get information, a lot of times a naive approach to that is just going to be, go get it. Go get the information. Well, sometimes your network's going to fail, the internet's going to fail, that exception is going to throw. If something somewhere doesn't catch it, your application is going to crash. So typically you want to catch that and say, okay, maybe retry it like 3 times to give the internet a chance to just kind of come back and recover from whatever that temporary error was. But you probably want to have log messages for each one of those so that you can figure out, am I losing network connectivity like a couple times a day or a couple times a minute? Mm-hmm. That might be really important to know. So if you just squash that exception, if you just catch it and then pass, you never have an idea as an application developer how often that section is getting hit. If you ever use an accept and a pass, I always recommend logging the exception. It will never hurt you. It's so little amount of data, relatively speaking, and you'll be amazed at how many times you come back and go, wow, I didn't expect to hit that then, or whatever. Never, if you ever see an accept like this, if you ever see this, this is developer warning sign right here. Do not do this. Right, Bill?
Well,
Nate? Oh, well,
specific exceptions.
I'm gonna have to go grab our code base. Okay.
You'll find a couple of those. There's always a good reason.
There's
And he's commented as well.
all right. All right, so all this is showing is that Python has some built-in functionality. When you catch an exception, notice I'm doing log.exception.
Can you assign the exception variable?
I could, but it wouldn't help me here. Because Python's just going to go, when I do this log.exception, it's going to go grab it knows what the most recent exception was, like from Python internals, and so it will log details about that particular exception. So when I run this, notice that I logged this to a file. So now I gotta go open that file, and this is what I get. I get the error message, which this can be kind of annoying if you're expecting your logs to be one per line, one log message per line, and you have some kind of parser that's going through your logs. Exceptions will tank you because they're not one line, obviously. We're going to talk about a little bit how to deal with that later. But this is really helpful, having logs, being able to go look at the logs that are in your, or the exceptions that are in your logs are helpful. And notice I didn't have to do any work on grabbing that stack trace or anything, just calling log.exception, automatically logged it at the error level, and automatically included the trace back after the message. Very helpful. Okay, let's talk about formatters. So a formatter is just a way to control basically the string representation of a message. So typically we've seen formatters that were either 3 pieces of information, and what were those? level, logger name, message, and we've seen formatters that just had a message, right? They didn't actually, those handlers didn't actually have formatters. So now we're going to control a little bit what the formatter is. So the first thing that I'm doing here, is I'm using basic config, and then I'm grabbing the logger, I'm grabbing its handlers, I'm grabbing the very first handler in its array. Remember, it can have multiple ones in its list. I'm grabbing the formatter from the handler, and then on the formatter, I'm using this underscore format variable which is what it's storing its formatting string internally. Really, what I wanted to show you here is what does the format string look like that basic config sets up. That's really what I'm trying to do here. And I've got to kind of dig into the Python objects to go grab that thing. Then I'm going to set up my own stream handler. We're going to see what the formatter looks like. Okay, you guys have seen, oh, well, anybody notice the difference between this line and this line? Any guesses what line 12 is going to print? Do I? So I set the handler up. What did I not do? I did not set a formatter. So actually what we're going to see is that there is no formatter. That's going to be none. Then I'm going to create a formatter. I'm going to set it on that same handler, and now I'm going to log something, and you'll see that this say hello now gets put into this string as the message. So this is the format string that basic config sets up. Notice it's exactly what we saw it was when we saw the message, right? It's level name, logger name, and message. Then we see that that formatter is none. So the handler that I added, the stream handler, its formatter is none. It's not been set. Then I add it, and I call the hello, and I get two pieces of output. Why do I get two pieces of output? There's two different handlers. Which ones?
Handler 0 and handler 1?
Yep, and where did they come from?
I can't answer that.
Okay, where did handler 0 come from?
Basic config.
Basic config set up a handler. Where did handler 1 come from?
You set up one.
I set up one. I set up a handler manually. That's where our two handlers came from. Where did that formatter for the first handler come from?
Default.
Basic config. There is no default formatter. By default, they will simply output the message. But basic config sets up a formatter. So that's where the first one comes from, and obviously the second one came from what I created and set. Make sense?
Mm-hmm.
Any questions? Anybody bored yet? This is taking a lot longer than I thought it would. I was concerned about kind of being out of here in half an hour, which is a common MO for me in my presentation. So if you need to leave, feel free to get up and leave. It's no problem. Okay, so now, one of the disadvantages about logging with strings is that we typically lose a lot of information, or we've got to parse that string to get all the information out of it. There's actually a lot of useful information. If you look at the Python docs, you can get the line, you can get the file, you can get the level, you can get the module name, you get all kinds of good information from that log record. But most of the time, when you look at a log file, a log message in a file, you just don't get into that. So what we want to do is we want to move to using a JSON string as the message format that we output. That's easy to parse. A lot of places will parse a JSON string for you. And so this allows us to now start logging structured data as opposed to text strings that have to be parsed. It's still technically a text string that has to be parsed, but it's at least a well-known format. It's a well-structured format, so we can call that structured data instead of text string. So I'm actually cheated. I've installed a library here, Python JSON Logger. They've done the hard work. I've created a JSON string, which basically just has all of the pieces of information that I want to get from the log record. So I create my file handler. I set my formatter on the handler. And I grab the logger, I set my level on the logger, I add my handler to the logger, because he's kind of old doing this a lot, and you do. And then I log my message and I log my exception message. So what should I end up with in my JSON.log file? Say it again. It'll be easier to read. Actually, it's going to be harder to read. But it's going to be easier for a computer to read. So we're going to have two records. One's going to be an info record, one's going to be an exception record. All right. Notice I said this is harder to read, right? And it is, because we got colons and commas and quotes in here. So the first message here that I'm going through, hello world is the message, level name's info, logger name is root, process ID. Did you see that? I got the process ID. That can be really helpful when you're trying to troubleshoot like your UW SGI server or a salary process to figure out. I actually used this. I had a production application that I would sometimes just get continual error messages in, and I couldn't figure out why, but I started to notice that they were all the same process. And it was a salary process. Salary is a queued task worker. And basically what was happening is I had a bug in my program that would basically tank a worker. Once that bug hit, that worker would always fail every time it ran. It could no longer query the database. And so I was able to track that down by noticing that this isn't actually on multiple workers. It's only happening on one worker. And I see a log message that indicates an error. And after that log message, I have nothing but log messages on that or nothing but error messages in that process continuously after that. So that gives me a good indication that something's going on tanking that process. And that would be very, very hard for me to figure out if I just had a log message and maybe the name of it. I would have no idea that it was just a single process that was always having that problem. And I wouldn't be able to pick that process's log messages out from all the other processes' log messages.
That JSON logger library that does that for you. Logs the process, I mean.
Yes, I added it here in the.
I mean, the Python log record has a ton of data on it available.
Yes, so
Pieces you want.
the Python log record gives you the process. The JSON logger simply puts it in a JSON format. I could have changed, you remember the last where I set my format string? I could have put this process thing in there and it would have given me the ID there, the process ID there. Okay, any questions on formatters or JSON formatting or why we would do it that way?
Can you run this into like the database server, database?
You could set up a handler. You could set up a handler that input the log messages into database fields, or you could set up a single database field like in Postgres, use a JSON column or a JSON V column and input the JSON, and without having to fiddle with having a different column for every field.
So one thing I'm confused about is that when you created the engine and you were using SQLite,
SQL commands, SQLite, yep.
is that on the logger? The engine is on the logger?
In that example, the create engine had nothing to do with logging.
Okay.
The only reason I had create engine in there was to trigger some SQL command to do some logging.
So you do a file handler and you're specifying a log file. Would that be where you create the database?
No, they're completely separate.
It's still
Yep.
So the database server would go where?
In my examples, there's no database server.
So you're basically all doing logging to a file.
Everything I'm doing here so far has been logging to standard error or a file. The whole SQL Alchemy thing was just to use a third-party library and to trigger some logs. That database that I created has nothing to do with logging. I just had to create a database in memory in order to get SQL Alchemy to run the SQL.
To me, it would seem like you're doing a lot of, if you're doing a lot of files and a lot of entries, you would run it into a database because you take advantage of the SQL engine to give you the speed and give you the flexibility of searching.
So maybe, but let me give you a better option because that's actually where I'm going.
Okay.
So this next message or this next option is everybody know what logly is?
No.
Loggly is just kind of a software as a service provider that allows you to ship logs to them and gives you a nice graphical interface to interact with. So you log in. Once you configure everything, which we'll talk about doing, you log in, and I don't have anything in here. That's weird.
I may have just ran that.
Oh. You stole my token. So just to be clear, I created a special API token to be in the GitHub database, and I will remove it as soon as we're done here. For reasons just like that. But no, that's fine. I don't mind at all. It doesn't surprise me. Okay, so hey, look at that. This works, right? So what we did, and we even if you notice when we expand this message, I hate their interface. But if I expand this message, notice that it's taken those fields and it's broken them out. So now I can actually go over here and I can filter on level name, and I only want to see the error messages, or I only want to see the info messages, or any of those other options that we now have. I can get really powerful searching. I can set up alerts now on if I see an alert, if I see a level name equal to error, I can have Loggly now alert my development team with an email and Slack channels. It's all pretty cool. I could set it up so that if you see one error message from a network call, you know, I said earlier API is failing. I could set it up so that 2 or 3 per 5-minute period is okay. If you get 5 per 5-minute period, 5 of those error messages in a 5-minute period, then the dev team gets notified to make sure that everything's okay. So really ends up being powerful to do your alerting based on logging. Assuming that your log, for really fine-grained stuff, that your logging provider ingests the messages fast enough. Sometimes there's delays, and so if you have something that needs to run every 5 minutes, and if they don't, like, let's say you're checking for a heartbeat message every 5 minutes, and they start to get 10 and 15-minute delays in ingesting messages, now you've got false positives that are really, really, really big. Which is something that we're dealing with a different logging provider that we use. Okay, so this is Loggly. Let's look at how this works. So Loggly provides an HTTP endpoint for you to ship them logs. So all I did was go read their docs, figure out what the URL is. All I did was I got a key. I created an API token, grabbed it, made it specifically for this, put it in the URL where they told me to. Set up the HTTP handler. Once again, it's just a handler, and everything else is the stuff that you've already seen. Right? So now, the handler, when it emits a record, it's making an HTTP post to this URL. Loggly is doing the rest. Loggly takes care of unparsing the URL parameters that the HTTP handler formats and ends up giving you structured data as a bonus. Anybody see a problem with this?
Third-party external data in the web.
Third-party external data in the web, you gotta make a call whether or not. Now there's good solutions like Elasticsearch if you wanted to run something like this in on your own hardware, that's fine. What else is wrong with this particular example? Well, the API keys in GitHub, sure. Anything else? Anybody see an HTTPS anywhere? No. So this stuff's all going clear text over the internet. So unfortunately, the HTTP handler that's built in does not support secure certificates as far as I can tell. If I was going to write this and I needed to use an HTTP post, I would write my own handler and use the request library to make the post. Really pretty simple. It'd be like 4 lines of code probably. So if you ever need to do that, don't shy away from writing your own handler and using the request library to post it. Okay. What's another problem with using, with making a direct connection at the point that you need to log? Connection could fail, right? What if you have a whole bunch of logs related to a connection failing, and you've got some cascading issues, and it would be really nice to know. Well, now you just lost all your log messages, right? So I don't really want to log out to a service like this. I would rather log to something locally, whether that's a file or some other type of service, and then have those logs shipped up asynchronously, right? Because I don't need it there at the moment. I don't need error handling in my application to take care of the situation when this log might fail. There's solutions for that. I don't want to mess with that. Anybody think about what a good solution for that might be? Somebody who's not looking at 13 dash whatever the file name is.
We use FileBeat.
FileBeat, yes. So you log all your stuff to files, and then you have FileBeat watch the files, and you ship up the logs. Okay? We do that too currently.
After you get that question answered, I've done the
Okay. Anybody? Last chance. Come on, there's some Linux heads in here. You should tell me.
Could you just store sysx and then check the?
I could put it in text, but this is what I wanted. Syslog. Somebody said syslog. That's what I want. I got syslog. Like, Linux machines have had a service for managing logs before FileBeat ever came into existence, and I have no idea why people are so insistent on putting another layer of abstraction when we've already got syslog in there. It works. Just use it. Like, all of these logging places, they're all like, here's documentation on how to have syslog ship logs to be. So my app ships writes to a local syslog instance. That local syslog instance will asynchronously make sure that all that logs get up there. It'll handle network retries. It'll locally store the messages on disk, so that if the machine crashes, it'll pick up from what's on disk. It does all of that for me for free. And I don't have to configure anything but syslog. Well, I got to configure my app to talk to syslog, and then I just got to configure syslog, right? I don't know, it makes sense to me. I don't have any files to rotate. It just works. So I'm complaining a little bit here. The guy that used to work at level 12 set up the whole FileBeat thing. I never liked it. I always wanted to use syslog. Now that he's gone, I'm coming back to syslog. I'm going to do what I should have done in the first place, was insisted on the better solution. Okay, what was the question?
You answered it.
Okay. All right, so anybody want to guess on what the file name for the 13th file is going to be? What?
No.
13-syslog. It was easy.
Okay.
All right, so here's how we get messages into syslog. The first thing that we're going to do is set up a format string. The reason that we're setting the format string up like this with the log demo 13 is that that's going to end up in syslog being the application name. So syslog itself is a structured system, it's a structured format, but I don't exactly understand how to use their format from here. All I know is that if I put the app name at the very beginning and put a space, it'll read it as the app name, which is helpful for me writing filters in syslog. So this is how I do it. So I set up that formatter. I set up syslog handler to log to devlog. Devlog is the Linux Unix socket that's available for the syslog to listen to by default. If you wanted to, hey Bill, can you guys keep going? Just keep going. Devlog is the Unix syslog socket, right? It's a socket. It's not. You can also have it connect through UDP or TCP to if that's where your syslog is listening. So you could also have it connected to someplace on the network if you wanted to. Make sense? So it doesn't have to be local. I like to have it local because I don't want the network to be flagging out on me and dropping log messages. Okay, so this ends up going to syslog, and by default, syslog is going to, you guys probably can't see this, can you? Tail-f bar log syslog. Okay, and you're going to get the last few lines here, and then I am going to run this. And that's not going to have any output because I don't have a stream handler configured anymore. That's fantastic. I like that. What the heck, cat? All right, hold on just a second. Oh, that's right. Okay. So in my logging config, I got to step ahead of myself. In my logging config, this is a R syslog, which is the syslog daemon on Ubuntu configuration file. This stuff sets up some queues to make sure that all those network files, if I end up hitting it really hard, it can save the stuff to disk. This sets up a secure certificate so that I can use TLS in my network connection. This sets up some templates which control how the message gets logged to a file or a remote server. And then this part is the filter. So what I'm saying is I want you to take the app name parameter, I want you to match it, make sure it matches logging demo, and then I want you to send it to temp logging demo.log with the logging demo template. I also want you to take that same message, that's the and, I want you to ship it to Loggly on port 6514. The double @ sign means use TCP instead of UDP, and use the Loggly format. This Loggly format, they give you this. They basically say, you know, this is what you want. Use this for your template string, and we'll parse it correctly. So I was looking in varlog syslog, but I think this is actually going to be in temp. It should be logging demo.log. And there you go. There were the messages that I just logged. So if I go back here and I run this again, now you'll see two more. Sorry, that's really small. It takes me too long to make those bigger. But at the bottom, you've got two more messages. So now, syslog, so this is great, right? Because not only can I direct, once it's in syslog, not only am I directing it to Loggly, I'm also directing it to a local file. In our applications, the way we would set this up, every application gets a user. So it might be like home, keg demo, and then everything inside of keg demo is all having to do with that app. So now, when I provision that app, all I need to do is set up a log directory and set up a configuration file for our syslog to take all of that app's logs and put them in the logs directory. So now, if I have a developer who's not a sysadmin, who does not have access to the box, if they need the log messages and they need them immediately, they can't wait for Loggly, or Loggly's having problems, or we're trying to debug Loggly, figure out why it's not working, it doesn't matter to them because they've got a local file that they can go to. Then I'm also setting up log rotate to make sure that those files are getting rotated. And now I've got a complete log solution. I've got logs locally for the application developers to log in and look at. I've also got logs out on Loggly for everybody to look at. That's usually the first place to go when you're trying to search, just because it's a lot nicer interface. And if I set up Loggly correctly, because Loggly will only hold your logs for so long, like 3 days or 14 days or 30 days, depends on how much money you pay them. Well, your log files locally are going to rotate out too. If you ever wanted long-term stuff, you can actually configure Loggly to ship your logs when they expire to S3. So now you've got a whole log pipeline, and all you've had to do was some really basic configuration in the Python app. You've had to drop an rsyslog configuration file for each app that you have to filter on that app name and put it in the right location. And you've got your local logs. I said that already. You've got something else. There's a third item there in my mind, but I can't do that at the moment. You've got Loggly shipping stuff off to S3 for you. Really top-notch, productive, best-of-breed solution right there, and you've not done very much work at all. All right, what else do I got? Anything? Do I got 14? Oh, yes, I do have a 14. Okay, so this is important. So as we saw here, these are not structured logs, right? You're just getting text here. Well, it would be really nice if in Loggly we got JSON logs. So if we go back and we look, let's see, did we get those come in yet? We did not get them come in. That's because that's why. Okay. All right. So notice the difference between you ran the latest file. You did? Huh.
You ran it twice.
Where'd the JSON messages come? Oh, that's right. Okay. These are not. These are from when we did the HTTP post. Okay, so notice that when we did the HTTP post, the way that handler worked and the way that Loggly was set up, it was able to read the data and destructure it. But for these text messages, it doesn't have any extra parameters for us. It has the parameters that come from syslog, but it does not have the parameters. It doesn't have. Oh, hey, look at that! It tried to parse some stuff out of there. It says Django. You see that? Yeah, they're pretty smart. They recognize the exception in there. What did they do for the? What did they do for this? Unparsed, just the message. Okay, so that makes sense. But we want to provide better logs than that, right? So let's combine JSON and shipping to Loggly so that when syslog gets the message, passes it off to Loggly, it's a JSON string, Loggly recognizes that, parses it. That seems like a win to me. Does it seem like a win to you? And I didn't have to use FileBeat for any of this. Okay, so now, this is kind of annoying here that you've got JSON in your log messages. That's not so helpful. What could we do? We could do both. How would we end up doing that? What would we have to do? What?
Another handler.
We'd have to have another handler to output a plain text message, and then we'd have to configure them with different app names. Remember how I added that prefix? We'd probably name one appname.text and another one appname.json, and then we would filter in our syslog to direct the text messages to the log and the JSON messages to log. Although honestly, I'm not going to do all that. This is, if you're a developer and you really need the file logs, you can figure out how to parse the JSON, right? It's not going to be that big of a deal. So I'm not going to do the extra overhead of logging 2 messages to syslog every time I have a single log. You could probably even figure out a way to have syslog. Man, syslog should have a JSON deparser, like splitter. Anyway, let's see if Loggly's got our message yet. It does. Okay, so these are now the last 2 that we just sent in. Notice that they are JSON strings, and they have all of this cool info. And we could add more. Remember, I set which fields I wanted. If you look through the, right here, if you look through the Python docs and you think there's some other log fields that are available to you, you just add them to that string there, and they're yours. I don't think I have a 15, do I?
No.
That's all I got. Any questions?